let's talk a little bit about exponential equations. You know, every so often you'll run into a different type of equations. We have quadratic equations. We have rational equations. Well, there's also, from time to time, we'll run into exponential equations. And what I want to mention today is two types of exponential equations. Type 1 is exponential equations with the same base on both sides. Turns out those are really, really nice if you can get them. Don't happen very often, but if they do, here's what you can do. For example, if I have 5 to the 7x plus 3 equals 5 to the 4x minus 5. Clearly, I've got the same base. It's an exponential equation, meaning really what that means, exponential equation, means the variable's in the exponent, right? An exponential equation is an equation that has a variable in the exponent. Here I've got variables in the exponent, but more importantly in this case, I do have the same base on both sides. This is base 5, this is base 5, okay? The reason these are so nice is because it turns out to solve these, all you have to do is cancel the bases out. The bases cancel. And you wind up with 7x plus 3 equals 4x minus 5. And that's a pretty nice little equation. You know, you run it to different types, but that's just solving a linear equation, get x on the side by itself, right? Yeah, so if you have the same base on both sides, you can, all right, so subtract 4x, be 3x plus 3 equals minus 5. Go ahead and subtract the 3, so you have 3x equals negative 8. Divide by 3. There you go. So the solution, x is negative 8/3. Now, this one falls into this category, but I have to do a little bit of adjusting, don't I? Isn't this over here on the right side, isn't that a base 3, or can I write that in base 3? Yeah, I can write 27 in base 3. How can I write 27 in base 3? This would be 3 to the x plus 5, but 27, isn't that 3 to the 3rd power? Well, wouldn't that be helpful here? Because if I write that as 3 to the 3rd power, what happens? The base 3's cancel out, essentially. So I have x plus 5 equals 3. So subtract 5, and you got x is negative 2. Okay? So that's the next type. It won't be difficult usually, but this, if we can do it that way, that is obviously the easiest way to go. All right? So let me give you a couple others. What if I have, just to remind you here, what if I have 5 to the 3x minus 4 equals 1 over 25. 5 to the 3x minus 4 equals 1 over 25. Well, we know 25 is a nice 5 number, isn't it? 5 to the power. However, it's 1 over 25. So if I rewrite 1 over 25 as 5 to the power, it's not 5 squared, what is it? How do we get 1 over 25? Negative 2, yeah. 5 squared is 5, but to get 1 over 25, make it a negative 2, right? 1/25 is 5 to the negative 2. So then again, the base 5's cancel, so I have 3x minus 4 equals negative 2. So I'm in business once again. Add the 4, divide by 3. X is 2/3. Okay? All right, what if I have 6 to the x minus 2 equals 36 to the 3x plus 1? 6 to the x minus 2 equals 36 to the 3x plus 1. Well, I can't cancel the bases there because I've got 6 and I've got 36. However, what can I do with a 36? 36 I can write as 6 to a power. Yeah, 36 is 6 squared. I need both of them to be the same base, so 36 is a nice base 6 number. It's 6 squared. Now, what about that? On the right, I have a power to another power. What do I do there? Remember on your rules for exponents, if I have x squared to the third, isn't that x to the sixth? I multiply. So I've got to multiply these two. Power to a power, you multiply. And so this will be 6 to the 6x plus 2. So I've got to multiply 2 times both of those. Okay? Then I can cancel the base 6's out. X minus 2 equals 6x plus 2. I'm going to go ahead and subtract 6x and add 2 to both sides, and that would be negative 5x equals 4 divided by negative 5. And I see x equals negative 4/5. Question or concern? All right, so that was type 1. Guess what type 2 is? If that's equations with the same base on both sides, or we can make both sides be the same base, type 2 would be when we have different bases on both sides. Now, type 2 is different bases on each side. So I'm not going to be able to make them, they're not going to be the same base, and I can't make them be the same base easily anyway. For example, a real quick example would be 12. Now 12 is a nice multiple of 3, but is it a power of 3? 12 to what power gives you 3? 3 to what power gives you 12? There's not a nice power of 3. 3 to the third is 27. 3 squared is 9. That's not a nice power of 3. 12 is. So that's what I'm saying. I can't make that be 3 to a power anyway nicely. So the technique on these are going to be different. And the technique on these is, what I'm going to do is I'm going to take the natural log of both sides. The idea is take the log of both sides, and the natural log is, in most cases, the best way to go. We could do common log. We could do any log we want. But natural log, let's stick with natural log. Take the natural log of both sides. That's going to be, for these type 2, that's ultimately what we want to get to be able to do. Take the ln of both sides. What we do to one side, we do to the other. So I'm going to take the ln of 3 to the x, ln of 12. So I've taken the ln of both sides. Now, why would I do that? Well, here's why I would do that. I would do that because the problem is I can't get rid of the bases because I can't make that 3 to a power. And so I need to somehow get x out of the power. And won't this do it? Because what can I do with that power of x now? Since it's a logarithm, what can I do with the power? By property 3, we were just doing. By property 3 of logarithms, doesn't that power pop out? Yeah. Since this is now a logarithm, I can bring this power out front here, and it'll be x times the ln of 3 equals ln of 12. Now, believe it or not, this is just a simple linear equation. I mean, it's got logarithms in it. We haven't had that before, but isn't that just x times a number? ln of 3 is just a number. How do I solve for it? How do I get x on the side by itself here? Let me write another step just to make sure not to confuse it here. how would I get rid of this ln of 3? Isn't it just times the x? So to get rid of something times an x, divide it. Yeah, just divide both sides by ln of 3. So x is equal to the ln of 12 divided by the ln of 3. Those are just two numbers, and that's why we chose ln, because I can punch ln 12 on my calculator, I can punch ln of 3 on my calculator, and it'll give me those numbers. And if I want, they'll usually want you to round it. And that would be the exact answer, but if we want to round it, all right, so ln of 12, 2.48. You don't have to write necessarily these out, but just to show you, take the ln of 12, then divide that by ln of 3. That's 1.09861, blah, blah, blah. Okay, so ln of 12, I'm going to just do this. ln of 12 divided by ln of 3. Should get 2.26185. Depending on how much they want you to round. If it's 2 decimal places, it would be 2.26. 3 decimal places would be 2.262. So how many ever places they want. Okay? So that's, you have the type 2, different bases on each side. You can't make both sides be the same base. This is it. Ln both sides. Okay? All right. So a couple more, because there are a few little twists that are going to happen. All right. So let's say I've got 500 equals 5 to the 2k. That falls into this category just like the last one, because 500, you're not going to be able to say that's 5 to a power, because 5 to the third is 125, 5 to the fourth is 625. So you skip over 500, see. So this, I can't make this be base 5. So what do I do in that case? Take the ln of both sides. So I'm going to take the ln of 500, ln of 5 to the 2k. And I do that because what can I do then with that? But one way I could go with that is that then brings, I'm able to bring down that 2k, because now it's a logarithm, and you can do that in logarithms. I can't do that just right here, but if it's in a logarithm, I can do that. So it's ln of 500 equals 2k ln of 5. All right, so that is, what do I do? Do I just divide, let's write a whole new step here. That's just 2 times k times ln of 5. That's just k times 2 other numbers, so divide off those 2 other numbers, 2 ln of 5. And so ln of 500 divided by 2 ln of 5 equals k, because that 2 cancels out, the ln of 5 cancels. All right, so that's a good answer, but what if I want to round, let's round that to 3 decimal places. Well, I mention that because if you're going to put this in your calculator all at once, you better be careful doing that. Okay? Here's what you should get. ln of 500 divided by 2 ln of 5. Should get 1.931. Anybody get anything different? If you're going to put it all in at once, here's what you need to be cautious about. You see, if I just put in ln of 500 divided by 2 ln of 5, what's wrong with that? If that's the way I put it in my calculator, what would be wrong with that? Well, the calculator sees divide by 2, but then times ln of 5. I want to divide by both of those, so instead, if I put it all in at once, I need ln of 500 divided by parentheses 2 ln of 5. See what I'm saying? If you're going to do it all at once, be sure you put parentheses around your denominator like that, and you'll get the right result. Okay? All right. Question, any other question or concern? All right, now, take a look at this one. E to the 0.05x equals 90.2. Now, that's one of these exponential equations. As a matter of fact, that's one that we, if you're talking about applications, you might encounter. What do I do to solve such a thing? Okay. Well, it is an exponential equation, so I need to get that x out of the exponent. And I'm not going to be able just to cancel out the bases, so what do I need to do? ln both sides. Take the ln of both sides. Got to do it to both sides. And what happens to the power? Power comes out, doesn't it? By property 3 of logarithms. Okay? Is that all right? Now, the good thing about this one is, this one even works really pretty nicely. Even nicer than the other ones because of this. We just talked about that. What is ln of e always simplified to be? It's 1. ln of e is 1, so this side is just 0.05x, isn't it? ln of e is 1, so that gets rid of the ln on this side because ln of e is gone. It's just times 1, so it's just 0.05x. So all I have to do to solve this one is divide by 0.05. That'll cancel the 0.05s out. So x is the ln of 90.2 divided by 0.05. If you put that to 3 decimal places, what do you get? I get 90.041. Or how many ever they want. 3 decimal places, that's what I got. All right? Okay. Now, say I have 40e to the x minus 7 equals 300. Well, the reason I need to mention this one is because of this 40 here. We haven't had, on any of these exponentials yet, where we had something else other than an exponential over here on the whatever side the exponential's on. Most of the time it's been on the left, but this 40, well, that's sort of a problem in this problem. I need to get rid of the 40. For this ln both sides to work, I need to have the exponential by itself. That's what I'm trying to get at here. So it first needs this e to the x minus 7, the exponential part, needs to be by itself. Needs to be by itself. Very important. So I need to get rid of the 40. How am I going to get rid of the 40? Move it to the other side. How do I move it to the other side? Divide by it, right? It's 40 times e to the x minus 7, so to get rid of the 40, I divide by 40. So this becomes e to the x minus 7. Different ways you can write it. Let's see if I just do a decimal. It's 7.5. With me? Okay? Now I can do my thing. I can ln both sides. The power comes out, so I have x minus 7 times the ln of e. Right? But the ln of e is just 1. So my left-hand side is just x minus 7, isn't it? So how to solve for x? I'll need to add 7, don't I? Now, one note on that, is that ln of 14.5? Why is that not the ln of 14.5? Because that's not an ln, that's just 7. So I take the ln of 7.5, which is 2.0149, plus 7 is 9.0149. That would be 4 decimal points. Okay? All right. One more. And I'm done. All right, what about 5e to the 2x plus 1 equals 20? 5e to the 2x plus 1 equals 20. Same deal as we had just now. I need to get the exponential by itself. Well, that means I've got two other numbers I need to get rid of. How do I get rid of the two other numbers? How do I get rid of the 1? Subtract it, get rid of the 5 by dividing it. So the correct way to do it is subtract the 1 first, so we have 5e to the 2x equals 19. Then divide by 5, I have e to the 2x equals, what was that, 3.8? Now I have my exponential by itself. So what can I do now? Well, I can take the ln on both sides. Power pops out, so I have x ln of e. And that's really nice when you have ln of e because it's just 1. So I have 2x equals ln of 3.8. So divide that by 2, and we've got my x. ln of 3.8 is 1.335. Divide that by 2, 0.675. Decimal places are how many ever.